Oh, hello. Good afternoon. This is Mr. Precella, and today we're going to be working on our first lesson over graphing, rectangular coordinates and graphing. And before we just jump into it, I need to do a little talking. So when we talk about graphing, I should have brought some graph paper, but I didn't. We're not actually going to be graphing everything on paper. We have some nice graphing tools, things that when I was in school would have been science fiction. But when we're graphing with our graphing paper, imagine the little grid lines. I'm just going to roughly sketch some graph paper. This is starting something new today, not new to the world of math, but new in the sense that we haven't done any graphing. When we're graphing, we have an x-axis and a y-axis. The x-axis is just a horizontal number line, and the y-axis is a vertical number line. On this rectangular coordinate system, or graph paper, we have the positive numbers going to the right on the x-axis, and up on the y-axis. Any future physicists, y'all don't need to come back one day and tell me, hey, in physics, we do it the other way. We put the positive numbers down. Well, this is math, and math does it the way René Descartes, the famous Frenchman, set it up, with positive numbers going up on the y-axis. We have negative numbers going to the left and down. And notice how this x-axis and y-axis break this graph, this region up into 4 smaller regions. Each one of these regions is called a quadrant. And we number, starting with the upper right-hand column, we call that quadrant 1. And then we go around in a counterclockwise, is that counterclockwise? Yeah, counterclockwise direction. Quadrant 2, quadrant 3, quadrant 4. That's a Q, and then 1, 2, 3, 4 quadrant. We plot ordered pairs. An ordered pair is a point in the form, it looks like those open intervals we were using the last time with interval notation, but it's not. We plot ordered pairs in the form x, y. The first number x tells us the left-right movement, and the second number y tells you up or down. And if you had graph paper, you could see, well, we don't have graph paper out here, but if you did, can you imagine the little squares if we drew the graph paper in? We plot ordered pairs. Let's plot the point. Ooh, this green is no good. How about the point 3, 2? This is an ordered pair. And you start right here at 0. This is always the starting point. So let me go ahead and give a little terminology. Since this is where you're going to start, that intersection there is called the origin. So we start at the origin. And to plot the point 3, 2, using the words left, right, up, down, we would move, since it's positive, right 3, and again the y value is positive, plotting the point 3, 2, up 2. So right here, right 3, up 2. Let's plot the point negative 3, comma 2. In which quadrant would negative 3, comma 2 be? Where is that? Oops. Is it quadrant 1, 2, 3, or 4? It would be 2, left 3, up 2. That's quadrant 2. Left 3, up 2. That's the point 3. Oops. 3. Oh, hey, is this one of, no. I have some erasable, that's not one of the erasable pens. Okay. Negative 3, comma 2. That point right there, the purple one. What about this point? Where would it be located? Negative 3, negative 2. Quadrant 3, we go left 3, down 2. So right there is the point, negative 3, negative 2. And I haven't used a black point. Hey, I'm wondering, could y'all figure out what's the next question? What point am I going to plot next? The key to any type of intelligence test is looking at patterns. Which point? I'm going to give you a hint. It's going to involve a 3 and 2.
Positive 3, negative.
Did y'all hear that? Yeah, positive 3, negative 2. What am I doing? I'm moving this around from quadrant 1 to 2 to 3. And if we plot the point right 3, down 2, that would be right there. Okay. In general, in quadrant 1, every point in quadrant 1 has positive x's and positive y's. I'm having to agree that that blinking monitor over there is very distracting or very annoying to me. So could y'all go through the rest of these and label them with pluses and minuses? In quadrant 2, all of the x's are, and all of the y's are. So negative, plus. What am I going to write in red down here for the signs in quadrant 3? Negative, negative. The x's are negative and the y's are negative. And in quadrant 4, x's are positive, y's are negative. Years ago, I was teaching a class in teaching trigonometry, and these little signs here are important in that course. We were going through this, and the student asked, do I have to memorize that? And, I wanted, that was a hard question to ask, because do you really need to memorize this, or can you think it through? I'm hoping you don't have to memorize plus, minus for quadrant 4. If you know that this is positive, the x's are positive, the y's are negative, then there's no memorizing involved, okay? Like right here, x's are negative, y's are negative. Should you just sit there and memorize it? I don't think you have to, okay? Now, some terminology. The x-intercept. I'm defining the terminology x-intercept. That's a point on the x-axis. In a moment, we'll be drawing some lines, and we'll see where does the line intersect that x-axis. Okay. If it were a point on the x-axis, what just happened? I don't know what's going on. Normally I can leave it untouched for longer than that, but okay. On the x-axis, if you have a point on the x-axis, Now this point right here where I have my pen at the number 1, how would y'all write that as an ordered pair? I'll get you started. To get to this point right here, you would move 1 unit to the right, and how many units up or down? 0. See, that's an x-intercept, a point on the x-axis. On the x-axis, the y values are always going to be 0, which means the x-intercept will always look like this. Some number, and then a 0 for y. Sometimes students start thinking, oh, x-intercept means 0 for x. No, no, no. You should be able to think your way through why it's a 0 for y, because you're not moving up or down. You're just here on the x-axis, so y should be 0. Now, could y'all write a similar statement for a y-intercept? A y-intercept is a point on the y-axis. So it would be like right there. There's a y-intercept. There's a point on the y-axis. If looking at this point right here at number, oh shoot, why didn't y'all tell me lower your thing? Okay, yeah. There. Right here at the number 5. How would we write that as an ordered pair? To get to this point, you don't move left or right, do you? So the x would be 0 and the y 5. A point on the on the y-axis. If it's on the y-axis, that means the x has to be 0. Any point on this y-axis has an x value of 0. And so the ordered pair will look like this, 0, comma, some number. Ooh, let me move this out of our way. Now, let me talk a little bit more before we do the first 2 problems. The first thing we're going to be graphing today are lines. In order to graph a line, we need 2 ordered pairs, and the equation of a line looks like this. AX plus BY equals C. This is where A, B, and C are numbers. The significant thing about a line, there's no exponents. Okay? If you don't have any exponents on x or y, then that's just a line. And the way we'll graph them is just by making a little XY table. And plot 2 points. Let's go ahead and look at problem number 1. Let me click there. Okay, it says, give ordered pairs that are solutions and graph the equation. So let me write it down. Problem number 1, 5y equals 3x minus 15. You might notice this isn't written exactly in the form ax plus by equals c. If you wanted it in that form, ax plus by equals c, then what would you need to do? You would need to move the x over here. But as long as it can be written like that, it's a line. The important thing, no exponents. Is our problem number 1 a line? Yes. No exponents, no x squared or y squared. So let me write, I forgot to write down, I think they've already given us part of the table. Let's see. What was it? Oh, look at that first line. It says, complete the ordered pairs so that they are solutions to the given equation. Notice how there's a 0 under the x. What are y'all thinking that's telling us to do? What are we going to do with this 0? Plug it in for x. So I'll do that over here. Plug the 0 in for x. We'd have 5y equals 3 times 0 is 0 minus 15. So we just have a negative 15 on the right. Oh, that's why I need another person there. Okay, there. Plugging a 0 in for x. We'd have 5y equals 3 times 0 is 0. Minus 15 would just be a minus 15. 0 minus 15 is negative 15. And now, what would we do to solve for y? How will we get the y by itself? Divide. Okay, let's divide both sides by 5. And we have y equals, is that going to be a negative 3? Negative 15 divided by 5? Negative 3. So there's our first ordered pair. Let me punch that in. Negative 3. Check it. And now, what do y'all think this new line is saying to do? What do y'all think that says? Notice where the 0 is now. Yeah, now plug a 0 in for y. Let's plug a 0 in for y. Oops, there. So we already have one ordered pair. You need 2 ordered pairs to graph a line. 2 dots to plot and connect. Now, when I plug a 0 in for y, I'm using blue for that. Putting a 0 here. The 5 times 0, that would just be 0, equals 3x minus 15. Now we need to figure out x. How would I isolate x? What would I do to get the x by itself? Add the 15. Is that what I heard? Add 15. And then what? How do I get the x by itself now? Divide by 3. It's sort of unfortunate that this first one here, we have the same numbers appearing over and over. 15 divided by 3 is 5. So x is 5. So what we've done is we've found 2 ordered pairs on that line. Now the way let me punch that in just so you'll be confident that I got it right. What number is it? A 5? Check it. And now here's something you'll do a lot this semester. First time we're doing these graphing tools. In order to graph on this, what I do is I say click to enlarge, because at this point I don't see the tools there. There's going to be some more graphing tools here. So we'll say click to enlarge. Now you see all the little tools. Like right there, line tool. If you hover over, I know you can't, it's too small for y'all to read this, but when you're doing it yourself on your own device, you can see hovering over the little thing. Absolute value tool. You'll use the absolute value tool when you have, guess what, in the equations. Say absolute values. You'll know when to use that tool. And then a circle. But the thing that we're using on this one, you've got to know, oh, it's a line. So you click the line tool, and then you'll follow this little yellow instructions there. I'm going to click line tool. Click the graph to plot the first point on your line. So the first point we had was, where was it? 0, -3. So 0, -3. Using my terminology, we go left, right, 0, down 3. What do we call that point? Is that an x-intercept or a y-intercept? Y-intercept. It's intersecting the graph right there. Notice in the upper right-hand corner of the yellow rectangle, it tells you what point we're at. So 0, -3. I just click there. Now it says plot the second point. What this little graphing tool does is at this point it's showing you every line that passes through 0, -3. But which one do we need? What's that second point? Is it 5, 0? So in terms of the words up, left, right, up, down, how do I get to 5, 0? I move right 5 and up 0. How do I know I'm at 5, 0? The upper right hand corner of the yellow rectangle. So we click here. You can't check your answer yet. What you have to do is say save, and that's going to move it to the graph right here, and then say check it. Okay? These are nice little tools we're going to use today. Okay? When I was a student 40 years ago, it would have been science fiction. Oh my gosh, more than 40, but 40 something years ago, let's say. Let's look at number 2. Number 2, 3x plus 4y equals 12. This would have been a better example if this 12 had been a 24. Back in the olden days when we just did everything on paper, I could change it and we'd do the good example. Here I can't, if I changed it to 24, I'll be getting the wrong answer, okay? So let's look at this. Instead of an XY table on this one, they're just writing out the ordered pairs. Fill in this ordered pair. Here it is, 0, comma, blank. What does it want me to do? What is that saying to do? Plug 0 in for x. If I, oh gosh. If I plug a 0 in for x, the 3 times 0 is just 0, plus 4y equals 12. Why did I write that 0 plus? I should have just written 4y equals 12. What do I do to solve for y? Divide by 4. And you see the reason I said this isn't a great example is because, boy, doesn't it make you think all I'm doing is just taking one of these numbers here. It just so happened that 3 times 4 gives 12. That's why we're going to wind up with these two numbers in our answer. 0, 3. Zero, 3. Okay. Now, what is this one telling us to do? Yeah. So we're going to now plug a 0 in for y and find the x. So once again, we're finding the intercepts. So if I plug a 0 in for y, the 4 times y is gone, and we would just have 3x equals 12. When I divide both sides by 3, what are we getting as the answer here? 12 divided by 3. Oh, shoot. Oh gosh. There. Sorry about that. Let me go back over what I just did. I'm plugging a 0 in for y. Remember, the ordered pairs are always x, y. Plug a 0 in for y. 4 times 0 is 0 plus 3x. So we have 3x equals 12. Divide both sides by 3. And we get x equals 4. Again, it looks like I'm just using the numbers here. No, that's not really it. Just change 12 to say 24. And you could convince yourself, oh no, it wouldn't be 3 then if there were 24. So 4 is 0. Let me type that 4 there. Check my answer. How do we use the tool? Say click. You got to say click, or because right here you don't see the tool. So click to enlarge it. It's a line that we're graphing. So we click that. And what was that first point? 0, 3. So over 0, up 3. Right there. I click it. Notice the ordered pair is stated up in the upper right hand corner of the yellow rectangle, right out here. But as soon as I do it, so here's every possible graph. And what was that other point? 4, 0. So this 4, 0, that would be the x-intercept. Notice how it's intersecting the x-axis. Click Save. And check. Any questions over that? Given ordered pairs or numbers to plug in. So we start off graphing lines. We're going to graph a lot of different stuff today. The next thing we're going to graph are quadratics. We've used that word. Quadratic means there's an x square. So it's going to look something like this. Y equals, do you remember the standard form for a quadratic equation? Ax squared plus bx plus c. The important thing is if there's an x square in the equation, remembering or getting out of it, if there's no exponent, then it's a line. If there's an x square, your graph is going to look like a U-shaped figure. It's something called a parabola. That U-shaped figure can open up or down. Today we're going to graph U-shaped figures and V's. The V, I think when I make my V, there's a sharp point. And when I make my U's, it's a nice smooth bottom. But the turning point, whether it's a U or a V, is called the vertex. So the way we're going to graph our parabolas, we're going to plot 3 points, but one of them has to be that vertex. Okay. And I'll demonstrate by doing problem number 3. Number 3. Next question. It says, for the equation y equals x squared minus 3, create a table with at least 3 ordered pairs, well, here are the 3 ordered pairs, that are solutions, and then graph the equation. So the first thing we're going to do is plug these numbers in for x and figure out y. And I'll plug in these numbers for x, figure out y, and then I'll show you how to do the graphing tool for that one. But let's first, let me write it down. Problem number 3. Y equals x squared minus 3. Make out my xy table. We're going to plug a negative 2 in for x. We plug a 0 in for x. And a positive 2 for x. 5 equals x squared minus 3. Okay. Just checking to make sure I didn't miscopy it. One day, one of us, either me or my brother, miscopied a problem. Y'all remember that? Did the wrong problem. Got it wrong too. Had to redo it. But okay. So y equals x squared minus 3. Start off. This first line means plug negative 2 in for x. Now be careful. Plug in a negative 2 in. We'd have y equals, now help me out, negative 2 squared. Negative 2 times negative 2 is 4. So we have 4 minus 3. What are we getting for y here? Y equals 1. Okay. So there's one of our points. Now, the second line, y'all caught up? Any questions? Is that projector still blinking over there? Or has it stopped? Oh, okay, so x equals 0. Plug a 0 in for x. I'll do that in this blue. So 0 right here. So we have y equals 0 squared. 0 times 0 is just 0 minus 3. So 0 minus 3, is that a negative 3? See how I'm getting my points here? And finally, the purple point. Here we plug a 2 in for x. So we still have y equals 2 squared. 2 squared is still 4, just like negative 2 squared was 4. So we have a 4 minus 3. It looks very much like this first one right here. And so what are we going to? Y equals 1. Now, let me punch those numbers in. Let's see, what are we getting? A 1, negative 3, 1. 1, enter. Negative 3, enter. 1, enter. Okay. And now we're going to graph this U-shaped figure. How do I know it's a U-shaped figure? The x squared. Okay, the x squared. So I click right here. Now let's see. Which of these tools? Well, because there's an x squared in it, we know it's going to look like one of these U-shaped figures, either opening up or down. Okay? So if you know what it's going to look like, it sort of gives it away what we're going to click on. Where do we see a U-shaped figure out here? Well, this first one, line tool. Second one, absolute value tool. You'll know when to use that because there'll be absolute value bars in the equation. Right here. Let's see. 3-point quadratic tool. That's what it says. I know it's hard to read, but that's what it says. 3-point quadratic. Is that what we have here? Do we have 3 ordered pairs? Oops. And quadratic? Quadratic means x squared. Yeah. So we're using the 3-point quadratic tool. And let me click there, and then we'll follow the instructions up here in the yellow rectangle. Okay? So I'm clicking 3-point quadratic. Plot the first curve. Click the graph to plot the first point of your curve. So let's see. The first one was at -2, 1. So in terms of the words left, right, up, down, -2, 1 means left 2, up 1. I look at the yellow rectangle to make sure I'm at the right point. And, now it says plot the second point. See, if you only plot 2 points, you're going to have a line. And that's what it's showing there. But what was our second point? Over 0, down 3. Hey, use our terminology. Over 0 means you stay on the y-axis, down 3. What do we call this second point here? The blank intercept. What is it? Which axis is it intersecting? Y. So this is a y-intercept here. Okay? That first point, the -2, 1, that's nothing. It's not an x-intercept. It's not a y-intercept. Got to have a 0 for it to be an x or y-intercept. And now it says plot the last point. When we plot that third point, that's when we're going to get a U-shaped figure. So right 2, up 1. I look at the yellow rectangle to make sure I'm at right 2, up 1. I am, so click. And I say save. And then check answer. Any questions over that? Well, I want to skip down to problem number 7 right now. Why? Well, this one is another quadratic. How do I know it's a quadratic? Because it has x squared, that little square. So it should be one of those U-shaped figures. What's wrong here? How does this differ from the previous problem? Perfect. It doesn't tell you which numbers to plug in. You've got to figure those out yourself. In general, if they don't tell you, just the numbers you used on problem 3 would work just fine. But what you need is a negative number, 0, and a positive number. Okay? So if they don't tell you which ones, you get to choose, but don't choose like 10. Why would you not want to use 10? Well, a 10, when you square it, that's going to give you what? 100? Look at our little graph. Our graph paper here is just -10 to 10. So don't go too large. It'll be up to you. Let me write it down. And then you choose the points. Let me see. So this is number 7. Y equals, they really made this one tricky. This negative x squared. Y equals negative x squared. That negative in front of that square is, the reason I'm saying this is kind of tricky, you remember we talked about the exponent only applies to what's right beside it. Just like with your calculator, Do I remember? Let me see, can I pull this calculator up? If I want to square a negative number, like that -2 squared that we used on problem 3, right here, -2 squared. We know -2 times -2 is a +4. But if you had done this, are you going to get +4 as your answer? No, the exponent only applies to what's immediately to the left. Here, the parentheses were immediately to the left, so that means you have 2 -2's. Here, if you start at the exponent and draw a line, all you're hitting is a 2. So you have 1 negative and 2 2's. But for problem number 7, where they didn't give you the numbers, I'm still going to write an XY table. And you're going to have to plug in a 0, and then a negative number and a positive number. I think using the same numbers we used right here would be a good idea. If you want to use -3 and +3, that's fine. I wouldn't use -4 and +4 because 4 squared is what? 16. And was that on the graph? Look at our graph paper. See, the graph paper is only drawn up to 10. So I'm going to stick with just -2, 0, and +2 on this one, even though it didn't tell me what numbers. Theoretically, you can use any number you want. But in reality, you've got to use numbers that'll get the stuff on here. That's why you can't use a 10. 10 squared would be 100. And there's no y values of 100. So I'm going to say, I'm going to stick with the same colors, a -2 and a purple 2. Now, one thing that makes this tricky is the fact that that negative is right here. So many students just ignore the negative, thinking a negative squared is positive. But no, this negative here means -1 times. You follow those order of operations. Do you remember, please excuse my dear Aunt Sally? You do exponents and then multiply. Let's do the +2 first. I'm going to do that +2 first for no reason other than I think that one's easier than the -2. If I plug +2 in for x, we have y equals, and instead of writing just negative, I'm writing -1 times, now here's where you do the squaring. 2 squared is 4. So what am I saying this y value is going to be? I'll give you the choice. Is the answer 4 or -4? -4. Okay. You'll see why I'm getting this -4. That little minus in the front sure does change things up. You square and then multiply by -1. Let's go ahead and do 0 next. That's the easiest one, isn't it? If I plug a 0, you already done it? What are we getting? Just y equals 0? Yeah. 0 times 0 is 0, so we have -1 times 0. Anything times 0 is always 0. So let me do this. For some reason, I like to put the little parentheses around the ordered pairs. Okay. It's not for some reason. Years and years ago, I had a student that was graphing like this. 0, 5, treating that as an ordered pair instead of reading it horizontally. And that's when I started putting the parentheses around it, because I thought, and I asked her at the time, does that make it clear? You're going this one and this one, not 0, 5. 5, 0. So one more to do. Plug a -2 in for x. This is the hard one. So we have -1 times, now let's square. What's -2 squared? -2, ooh, y'all, I wrote a y here. That should say x. Y'all see that? Oh, do y'all see? Okay, good. It should be an x equals -2. They do like my brother there. Just there. X equals -2. What's -2 times -2? 4. -1 times 4 is -4. Notice we got the same answer here and here. Should that have shocked us? No, we want a U-shaped figure, so whatever's happening on one side should be happening on the other. Okay, so we plot these 3 ordered pairs. Well, first, oh wait, I don't have to type those in. On this one, it didn't give us the numbers. All we do is plot. But just like up over here on number 3, did you notice how we got the same y value here and there? Did that happen here? Yeah. If you hadn't gotten the same number, you're not going to get the parabola. You should be expecting that. Okay, so I'll say click to enlarge. It's x squared, so it's a quadratic, and we had to know to find 3 points. Okay, so I'll click there, and now the instructions are just like the other ones. Plot the first point. Our first point is left 2, down 4. Now plot the second point, but left 2, down 4, okay. Plot the second point, what is that, 0, 0. And then finally the third point, 2, -4. So that would be right 2, down 4. I'm looking in the upper right-hand corner of the yellow rectangle, and yes, that's 2, -4. And save it. And check. Hopefully it's clear to y'all why I didn't plug in like a 5 or a 6. If I'd plugged a 5 in and gotten a -25, you see, theoretically you could have, but not in reality when we're here, because our x's and y's are only between -10 and 10 on this graph paper. Okay. Any questions there over these quadratics? Let's see. We ready to try another one? Or a different type? Writing. Oops. The next thing we're going to graph, we've graphed quadratics, that's with a square. We're also going to graph cubics. And y'all want to guess what exponent a cubic has to have? A cube, good. If you have an exponent of 3, you're going to have a cubic. And for this one, they're just going to give you numbers and you plug them in, okay? Let's see. Let's see. I have to know which one is the cubic. Okay. Number 6. See, for the equation y equals x cubed plus 2, create a table with ordered pairs and then graph the solution. When we get started with looking at the graphing tool, which tool to use, there's how many points here? 4. And then it's a cube, so look for the one that says something about 4 points and cube. But let's do the plugging in first. Let me write down the problem. This is number 6 that I'm doing. Y equals x cubed plus 2. X, Y. Now remember, a cube means a number times itself 3 times. A -1, a 0, a +1, and a, what's that, 2. Okay, so number 6 is our cubic. Well, in words, what are we going to do to these numbers here? We're going to plug them in for x and find y. That's right. So let's start with this first one, the red -1. Plug a -1 in for x. If I plug a -1 in for x, we have y equals -1 times -1 times -1. You know what? I'm going to write this out like that. Y equals -1 cubed plus 2. -1 times -1 is +1 times another -1 would be -1. Then plus 2, what are we getting y equals there? -1 plus 2. Are y'all following what I've done? 1. Are y'all ahead of me? Sometimes I get ahead of me. And I wanted to show y'all on a calculator. And I know y'all can multiply 1 times 1 times 1, but just for illustration purposes, if you wanted to type this into your calculator, parentheses, -1, and to get a cube on here, I use the little caret top symbol, 3, that's how I enter a cube, and then plus 2. But these numbers are so small, I'm not saying you need a calculator. -1 times -1 times -1. I know y'all can do that. Like a 0, plugging a 0 in for x. 0 cubed, I know y'all know 0 plus 0, 0 times 0 times 0 is just 0. So what are we getting? Just +2. Now, let's plug in, is that a purple 1? Oh, okay. If I put a 1 in for x, 1 cubed plus 2. 1 times 1 times 1 is just a 1. Plus 2. Are we getting 3 for the third point?
Yes.
And one more. Y equals, excuse me, what about y equal x So I'm plugging a 2 in for x. 2 cubed, don't say 6. That's the common mistake. 2 times 2 times 2. 2 times 2 is 4 times 2. Is that going to be an 8? Plus 2. Are we getting 10? Why? Oh, ooh, bottom of the page. So let me type those numbers in if it hasn't already timed me out. Let's see. 1, 2, 3, 10. 1, 2, 3, 10. Notice with the cubic, the y values will start getting big really quickly. Notice how it went from 3 to 10. If you'd put a 3 here, 3 cubed would not be a 9. It'd be 27 plus 2. Oh, okay. So sometimes the y values will be so small. That's why I like to look at the yellow rectangle to see what point I'm at. And again, your vision might be better than mine. Let's see, which one are we going to click? Is it a line, yes or no? No. Is it an absolute, this one says absolute value tool. It's not that, okay? Because there's no absolute values. You'll know when you get to an absolute value. Is it a 3-point quadratic? No. We have 4 points and a cube. What's this little squiggly mark there? Can y'all read what it says? 4-point cubic tool. Well, yeah, you could read it. It's, can you see it? I should have said. Let's to see what that says. But this is the point that says 4-point cubic. So we click there, and it just says plot the first point. So left 1, up 1. Ooh. Am I left 1, up 1? Yes. Looking at the top, the right-hand corner of the yellow rectangle. So I'll click there. Then over 0, up 2. Am I at 0, 2? Yes. These y values, the y marks are so small. That's why I like to look at that yellow rectangle. It's hard to see, isn't it? And then 1, 3. Oh, you see, if we stopped after just one of these, well, it looked almost like a parabola, but I don't think it is. Look at that. It looks like it's just a line. Am I at the correct point, the third point? 1, 3, yeah. So at this point, it looks more like a line than anything else. Once we plot that fourth point, 2, 10, now you'll start to see the little squiggly shape coming in. Right 2, up 10. Right 2, up 10. There. I say save and check. Any questions? This cubic tool, it's real easy to use. Just plug in the numbers and then plot the ordered pairs. 1, 2, 3, 4 in the order they have listed there. I've never tried plotting them in a different order. Okay? Let me see. Can't hear you. Let me see. Yes, you got to plug in a number for x, and that'll give you the y equal value. Okay? So there's no way around it. Plug in some numbers for x. Now, Okay, not last, we have two more things we're going to do. Only one more graphing tool. And it's going to be, oh my goodness. I've already filled up two little parts of this book. Okay. Well, my brother writes bigger than I do. You haven't noticed because he got the penmanship award. In elementary school, he got that penmanship award over and over and stuff. I think I got it 1 year, but we were in different classes. But either way, I just think that the people in my class wrote better. The last thing, or not the last tool we're going to use are absolute value tools. To graph an absolute value equation, and you'll know it when you see it. It has the absolute value bars. It's going to look like a V. And the turning point on these V's are just like the turning points on a parabola. They're called the vertex. But, oh gosh, I guess I'm going to go ahead and tell you. This absolute value tool is the trickiest of them all, okay? That's why I saved that tool for the last one. So, with the absolute value tools, the vertex, this is going to be important, occurs when the stuff inside the absolute value bars equals 0. I probably should have problem 5. I should have shown you what these are going to look like. These are the absolute value bars. Remember those? Give a graph with at least 3 ordered pairs and graph the equation. So let's go ahead and do that. But there's going to be something different about the, it isn't going to say plot the first point, plot the second point, plot the third point. When you click on the absolute value tool, the first thing it says is plot the vertex. You've got to know what that sharp point is first and plot it first. But I'm getting ahead of myself. Let's do problem 5. Y equals, I'm going to put those absolute value bars in red. Absolute value of x minus 9. Let me draw my XY table.
Thank you so much.
Oh, anytime.
I'll see you soon.
Bye-bye.
Bye-bye.
Okay, so in words, what are we doing on this one here? Complete the following table. It's telling us to plug -1 in for x. Okay. This is one where we have to do it one at a time. Do one, type in the answer. So a little bit slower. So plugging in a -1 for x, we would have y equals absolute value -1 minus 9. You know what? Let me do different colors. All of this. So I plug the -1 in for x. So inside the absolute value bars, we have It's negative 1 minus 9. Negative 10. But that's not going to be our y value. You've got to actually take the absolute value. What's the absolute value of negative 10? 10, okay? So positive 10. Is that point, is this ordered pair the vertex? No. The vertex occurs when the stuff inside the absolute value bar equals 0. So this one is not the vertex. But we're going to have to know which one's the vertex, because that's going to be the one you've got to plot first. If you don't plot it first, it's going to count it wrong. Oh wait, I've got to punch in that number, don't I? A lot of back and forth. So type in a 10. That's right. The next number they said is, now plug a 9 in for x. Let's plug a 9 in for x. That's the second line here. If I plug a 9 in for x, x equals 9. What are we going to have there? A y equals absolute value of 9 minus 9. Oh gosh, that's not 19 minus 91. Okay, trying to make it where it's clear that it's not. What do we have inside those absolute value bars? 0? That's right, 9 minus 9. And the absolute value of 0 is 0. What did we just find? The vertex. The vertex occurs when the stuff inside the absolute value bars equals 0. So I'm going to put a V right here, again, because the graphing tool is going to say plot the vertex first. So you've got to know which one's the vertex. So let me punch in a 0. And a 12. Let's plug a 12 in for x. So x equals 12. So I'm plugging a 12 in for x now. We'd have y equals absolute value of 12 minus 9. That's not 112 minus 91. What number do we have inside the absolute value bars? 12 minus 9, 3. And we have the absolute value of 3. What's the absolute value of 3? Just 3. So y equals 3. We've already determined which one of these is the vertex, but definitely this one isn't. Okay? The stuff inside the absolute value bars didn't equal 0. Where the stuff inside the absolute value equaled 0 was right here when x was 9. So we plug in 3. And then say OK, click. I'm laughing because I remember one semester I had every student in the class email me and told me that Pearson was wrong. They counted their problem wrong when it was right, and it was one of these absolute value bars. Let's see. Here's the one that says absolute value. So I click there, and what does it say? It doesn't say plot the first, or click to plot the first point. They say plot the vertex. Which one of those was the vertex? 9, 0. Oh, 9, 0. You gotta plot that vertex first. Am I at 9, 0? Yes. Then it just says click the graph to plot another point. Look at this. If you just move your mouse around, you're only going to have to plot 2 points. We found 3, but you only need 2. You've got to plot the vertex first, and then it's up to you. Plot one of the other points. What were those other 2 points? There was negative 110 and 12, 3. Which one do y'all want to plot? Negative 110 or 12, 3? 12, 3, so right 12 up 3. Ooh. Oh, oops, right 12 up 4. Darn. Not right 12 up 3. There. And then you say save it. So even though it told us to find 3 points, you don't plot first point, second point, third point. You plot the vertex first, and then one of the other points. If you had plotted left 1 up 10, well, I should have shown this earlier, but if you can sort of imagine, here's left 1 up 10, it would give you that point right there. You'd still have the same V-shaped figure. Check it. Okay. Oh, did I say next question? Oh, I didn't mean that. These absolute values are the trickiest. I'm skipping down. When you're making these assignments, there's a little thing where you say, and it sorts it the way Pearson thinks it should be done. That's why I'm jumping all around. How I want to do it isn't the way they had it sorted. Okay? So problem number 8. We've done a problem similar to this here. Which one was it? 7, where they didn't give us the table of points. Number 8. It's an absolute value, but they didn't give us the table of points. We're going to have to come up with those points. Okay? So let me see. Number 7. Y equals the absolute value of x plus 6. I'm not just going to randomly choose numbers. In order to graph an absolute value, you must know that vertex. Lower this. The vertex occurs at the x value that gives you a 0 inside here. What x value would give us a 0 inside these absolute value bars? Negative 6. Negative 6 is the x value that would give you a 0. Okay. That's the vertex, and that's got to be the first point you plot. Then, the way the graphing tool works, it says, plot the vertex, plot another point. At this point, it's completely up to you what number to use. Just plug any other number you want in for x. In case you're wondering, how did they decide on negative 1 and 12? They were just randomly choosing numbers. The vertex had to be 9. That's the one that gave you a 0. Just like right here, Negative 6 is the only thing that's going to give us a 0. But what about another number? Choose some other number. How about a 1? If I plug a 1 in, I don't want to get something too big to fit on the graph. I'm not going to plug 20 in because that might be too big to fit on the graph. So what about a 1? If I plugged a 1 in for x, is that pretty easy to figure out? What are we going to get? 7? 1 plus 6, 7. Absolute value of 7 is 7. So here are the two ordered pairs. If you want to find a third one, that's fine. But remember, over here, we didn't use all three of these points. You used the vertex and one other point. So I'm going to plot negative 6, 0. And then my one other point will be 1, 7. Back. Are y'all caught up with me? Y'all following what I'm saying? It's a little different when they don't give you the numbers to plug in and you have to figure it out. But it's an absolute value, plot the vertex. Negative 6, 0. There. Okay. And now, here's every V-shaped figure that has negative 6, 0 as a vertex. How do we decide which one it is? Well, plot another point. Up here it says plot another point, and I'm going to plot 1, 7. That means right 1, up 7. Am I at 1, 7? How do I know I'm at 1, 7? Well, the upper right-hand corner of the yellow rectangle. Save it. Check it. Any questions there? Vertex is tricky. I mean, the absolute value is tricky because the way you've got to plot the vertex first. Okay. Let's see, we still have, we only have 10 problems here. Starting with 11, it's review of older stuff. We need to go back to problem number 4. Every time I'm teaching this, I'm wondering, will this have a tool? No, this is the way it used to be, way back 20 years ago, when it was Addison Wesley, my math lab. Everything was multiple choice. Students liked it better, but it just says, graph this equation. This is a square root equation. One day there'll be a square root tool. I've been saying that for almost 10 years, so maybe maybe they forgot they don't have a square root tool, and that's fine. They can do it as multiple choice. What you have to be careful about with square roots is on a graph, we have no imaginary numbers. The x-axis and y-axis are just real numbers. So we're going to plug in numbers for x and y. But you can't you can't plug a 0 in for x. If I tried to plug a 0 in for x, 0 minus 1 is a negative 1. And do y'all remember what the square root of negative 1 is? Give you a hint. It starts with I. Y'all didn't get the joke, did you? It is I. So you can't have no, we don't want any. If we have negatives under there, then that's an imaginary number, and we don't want it. Why? There are no imaginary numbers on the y-axis. So we can't plug a 0 in. What about a 1? If I plug a 1 in for x, 1 minus 1 is 0. What's the square root of 0? Say 0. 0. The square root of 0 is 0. We can't have a negative under the square root, but it's certainly fine to have a 0 under a square root. Now let's just keep going from there. After a 1, what about a 2? Notice I'm not putting negative numbers in, because if I put negative numbers in, then that's going to give me imaginary numbers under there. Okay, so plugging a 2 in for x, not going to be hard. What would we get? 2 minus 1 is 1. The square root of 1 is 1. Where's my calculator? Oh, clear. To get a square root, I go second square root. 2, first 1 minus 1. The square root of 1 minus 1, that was the first one we did. The square root of 2 minus 1. 2 minus 1 is 1. The square root of 1 is 1. Now, if we continue, like a 3, if we plug a 3 in for x, we'd have 3 minus 1, which is a 2. So we have a 2 under the square root symbol. The square root of 2 is a decimal number, 1.414. So you might not want to use that. But if you want, okay, just a 1.4 approximately. I always like to ask this question. Most times students have no idea what I'm talking about, but I'm going to ask it anyway. What's the next number I could plug in here to not get a decimal number? We got a 0 for y, a 1 for y. What about a 2 for y? What would x need to be for me to get a 2 right here? A 5. Exactly. Did y'all hear that? Why 5? 5 minus 1 would be 4, and the square root of 4 is 2. I've plotted more than enough points. This is multiple choice. I've plotted more than enough points for us to, or I haven't plotted, I've found enough points. Okay, so, I'm actually going to sketch this out. Wait, let me switch over to the paper. Yeah. Okay, there. Got there. Okay. If we just started plotting these points, right 1 up 0. This is 1. So right there. Then right 2 up 1. Right there. And if you want to go right 3 up 1.4, okay.
I'd skip that.
Yeah, and go to right 5 up 2. If we just started connecting these dots, it's going to keep going and going, slowly up. But do we have anything over here? Is there any part of the graph over here? Well, no. Remember what we said. We can't have negative numbers under the square root. There's no part of the graph over here. So looking at your answer choices, let's see, do that.
A.
Oh, look at that.
That looks close. Let's see, what about the others? B.
No.
Clearly not.
That's what would that graph look like? Say it, impress me with the terminology. That would be what?
What sort of function?
Quadratic, okay? It has that U-shaped figure, so same thing for D.
Oh, wait.
You see, D is another
D.
U-shaped figure. That would have been a quadratic, which we don't have. The only thing it could be is A or C.
No, even C is
C.
so dramatically
Mac.
wrong. It's got to be A.
But blow it up, I wanted to mention the scale. This might be the first time, only time today, that notice the scale on the x-axis, each mark isn't 1, is it? What is each mark going to be? 2? You'll see 2, 4, 6, 8, 10. Well, it doesn't show it, but it has no 5 marks. So there's nothing real sophisticated about square roots. You're just plugging in numbers that'll give you real numbers back. You don't want an imaginary number. Okay. Now, do you want to do distance and midpoint? We're up to the last one, so I'll do it.
Oh, okay. Keep
My voice is okay. So we're through with the graphing.
I should mention. Oh well, I'll wait to mention this until we're through recording.
Okay. So we have one other thing we need to do. Problems 9 and 10 both deal with some formulas. Show my page. You don't need to show this. You don't need to show those problems here. We're going to get 2 formulas. The distance formula and the midpoint formula. Distance formula and midpoint formula. I need to write 2 ordered pairs using variables. Each ordered pair is XY. Ordered pairs are always XY. But if I just use XY, how do I distinguish the first ordered pair from the second one? To do that, I'm going to put subscripts. These are not exponents. X subscript 1 and Y subscript 1. That just means first X, first Y. Having seen that, could y'all guess what subscript I'm going to put right here for the second? 2. Okay. X subscript 2, Y subscript 2. This is a comma. It looks like it says X21. It is not X21. It's just that, well, that makes it much better. But, okay. Let me state the distance formula first. The distance, between 2 ordered pairs, X1, Y1, and X2, Y2, is calculated by this formula. D for distance equals the square root this one's the more complicated formula. Okay, it's second X minus first X squared plus second Y minus first Y squared. I'm going to go ahead and state both formulas before I actually do an example of these. But it's second X minus first X, subtract them and square them. Second Y minus first Y, subtract and square. Add it up and take the square root. It sounds worse than it actually is when I say it out like that. Now, that's the distance formula. The ordered pair that lies midway between 2 points is calculated by, y'all know what an average is. If I said, how do you average two numbers? What would you say? How do you average two numbers? Take the two numbers and add them, and then, yeah, and if it's just 2, divide by 2. That's how you calculate the midpoint. You average the x's, and then you average the y's, okay? In other words, okay, to average the x's, you just add up x1 plus x2, and then divide by 2. And then to average the y's, could y'all tell me what I'm about to write right here? How do I average the y? y1 plus y2, divide by 2. And the midpoint is an ordered pair. You've got to put parentheses around them, as you'll see in the example I'm going to do. Okay? If you forget to put the ordered pair, the parentheses around the ordered pair, it's going to count it wrong. But I'll demonstrate that. 9 and 10 are the exact same thing. I think 10 is the one I want to do as an example because it has a lot of negatives. And usually it's the negatives that give students trouble. So what are these points? It says for the point P, negative 10, comma, negative 23, and the point Q, they're giving you a lot of stuff you don't need. You don't need that P and Q. Just the two ordered pairs are all that matter. Negative 10, negative 23, negative 3,
negative 18.
and negative 18. Whenever I use a formula, it doesn't matter what formula. If it's a quadratic formula, I always keep rewriting it over and over, okay? I also like to identify the variables. I'm actually going to write x1, y1.
Wait, I haven't switched
Oh my
yet.
goodness.
I didn't realize you were ready to start.
Yeah.
Okay.
Okay. So here's my first x and my first y. Right over here, here's my second x, second y. I'm going to rewrite this formula because I'm just going to plug in d equals red square root second x minus first x, second y minus first y. So plug it in now. So when you're taking your test, if you have a notebook, you want these formulas somewhere where you can reference them or on a sheet of paper, or just memorize. Second x, that would be what, a negative 3 minus, what am I going to put in place of x1? Negative 10. Do y'all see why I'm doing the one with a lot of negatives? because that's what's sort of messy. What's happening right here? We have the red minus from the formula, and then we have a blue minus also. So this minus and negative is going to become what? Yeah. Okay, so I'm going to go ahead and do this first set of parentheses. Negative 3 plus 10, is that just going to be a 7? Anyone following what I'm doing? Now over here, y2 minus y1. Y2 was a negative 18. Then minus is from the formula. That's what I'm trying to show with that red minus. The red minus is directly from the formula, but what's about to happen? It's going to change into a plus, isn't it? Because y1 is a negative. What are we getting in this second set of parentheses? Negative 18 plus 23 is it a 5? Squared? Oh, wow, I hate to say look over this because it looks a mess. You'll see how I'm getting this? x2, negative 3 minus a negative 10. That minus and negative becomes a plus, so that's where we get 7. y2 minus y1, negative 18 minus a negative 23, that would be a plus. Negative 18 plus 23 is 5. Now, let's see, what are we getting here? 49, 7 squared is 49, and 5 squared is 25. Oh, it was about this. I was adding wrong. I thought it was 64, but no, it isn't. What are we getting under that square root? 74. Can we simplify square root of 74? 2 times 37, aren't those the only two numbers that multiply together to give 74?
Other than 1 and 74.
Well, yeah. And so neither of those are perfect squares. So here the distance is square root of 74. That would be the exact value. It's going to be 8 point something units.
We click the square root hot button. We type the 74 underneath. Now the midpoint.
Okay, so I shouldn't have started so low on the page. So, I don't know why I've never done this before. I'm going to do it right over here, just so we can see the numbers and stuff here. I've never thought to do that, Tim. Have you? I know you don't. You just sort of use this page over here as scratch paper. So, to calculate the midpoint, let me write that formula down right here. You're averaging the x's and dividing by 2. So average. You're adding the x's and dividing by 2. That's how you average. Then add the y's and divide by 2. So I'm just plugging into this midpoint formula. This one generally students think is easier because there's no square root or squares. You're just adding it up and dividing by 2. So x1 plus x2, negative 10 plus a negative 3, and then negative 23 plus a negative 18. What are we getting up here on top? Negative 10 plus a negative 3 is negative 13. Now, what about the y's? That's going to be, see, negative 23 plus a negative 18. I'll get us started. It's going to be negative 23 plus 18, 41. And 13 over 2, early, all you could do is write it as 6.5. We don't write mixed numbers or decimals here. Same thing for 41 over 2, that would be 20.5. You just stop right there. So negative 13 over 2, comma, negative 41 over 2.
If you plotted these 2 points that you were given, drew the line segment connecting those 2 dots, this point here would be right there in the middle of that line segment. That's what you found geometrically. That's what you're finding with that midpoint.
Now,
any questions there?
Plug it in. Make sure it says type an ordered pair. Do you see that? So
I thought they gave you the parentheses. They might do that for number 9, though.
I don't think so.
Oh, okay.
It's a different one.
So it's negative 13 over 2. Get out of the denominator before you type your comma.
If you put the comma
Negative 41
down here,
over 2.
it'll probably count that wrong also. Commas should not go in denominators of fractions. If you had to put those big parentheses, it would count it wrong. Okay?
Well, you just type a regular parenthesis.
Yeah.
The program automatically makes it big to hold the entire fraction.
Okay. A lot of stuff. It's not as involved as calculus, I think. Okay. So, any questions that you want recorded? And stop.